All right, we're going to look at section 1.3 when we start actually putting numbers to associate with some of our sets of data. Typically, this is with our quantitative sets of data. So we're going to try to use these numbers to describe what our distribution looks like. So in section 2, we talked about the center and the spread and the shape, and now we're going to actually talk more specifically about how we can measure those things. So first we'll talk about the measures of the center. So the measures of the center are things you've probably heard of before. We typically do the measures of the center with the mean, median, and mode. So these are all different types of averages, and all ones you should have seen, but they all have some certain problems with them. So the first one is the mean. So the mean is what you probably typically heard of as the average. It is when you add all the numbers up and divide by the total number of values. So if you want to look at it, we have what's called x bar equals summation of x sub I over n. Now the sum of x sub I, this just means add up all the values in your data set and then divide by how many. Now this value, this symbol here, is what is called the sample mean. Now the sample mean is the average or the mean of the sample set of data. If you're doing a whole population, let's say you did collect data from the whole population, then it has a different symbol, and that symbol is mu. So this symbol is for the population mean, and that is a very important thing in statistics, but the thing we usually calculate is a sample mean because we have a small part of the data set, we add them up, and we divide by that total. That's the mean. Now just a couple things about the mean. It should be rounded to one more decimal place than occurs in the raw data. So if your data is to the nearest tenth, you should put your mean rounded to the nearest hundredth. The mean is usually not one of the data values. And that's pretty easy to think about because if I have 3 kids and someone else has 2 kids, our average number of kids is 2.5. Well, that's obviously not a number that's going to appear in a data set. Final thing, and this is really important, is very large or very small data values have a big effect on the mean. So if I add a large number or a small number relative to the rest of the data set, it is going to make that mean change quite a bit. Okay, the second way we'll measure average or center is what's called median. So the median is the midpoint of the data. And so it's basically the point where half of the data is bigger than that and smaller, and the other half is smaller than that. And that's always true if obviously the data is ordered. Now the nice thing about the median is it is not affected by large or extreme data values. So if I have a median and I add a really, really big number, it'll change the median, but it won't change it as much as the mean. So the median is what we call more resistant because it does not change as much when you add larger values to it. So let's go ahead and look at a couple examples. It says here we're going to talk about how to find these on the TI calculator, and we will do that, but I'm going to make a second video to kind of show you that. So there'll be a second video that kind of shows you how to do all the calculator functions. So this first one we're going to kind of try to do everything by hand, at least talk about it by hand, and then in the next one we'll talk about how to use some of the calculator functions. So I want to find the mean and the median for these data sets. So the first one is the number of tornadoes that have occurred in the U.S. over an 8-year period. So that is obviously not the whole history of the U.S., so this is just a sample data. So the sample mean will take all these numbers, 656, 684, 702, 764, 856, 1132, 1133, and 1303, and then we will divide this by 8 because there are 8 data pieces in your data set. So when I work this out, I am going to get 903.75. But since we went around to only one more decimal place than our data, So they're all to the whole number, so I'm just going to round to 1 decimal. So 903.8, and our unit in this would be tornadoes. So there's an average of 903.8 tornadoes. Now, for median, we can do the median as well. So the median for this data set is the middle. Well, there seem to be 8 data pieces here, so the middle is actually in between these two. If it's an odd number, it's going to turn out to just be one of the data values. If it's an even number, it's in between these two. So all we'll do is we'll just split these two. So we'll say 764 plus 856 divided by 2. So that's going to give me 810 tornadoes. So what you can kind of see is the median is around 810. So the mean has gotten larger because you had some of those larger values. We had those years with some bigger tornadoes, 1,303 and things like that. So it made the mean a little larger than the median. All right, let's look for one more example. It says 7 customers purchased the following items at the grocery store. So we want to find the mean and median of those as well. So the mean is going to be 1 plus 5 plus 7 plus 12 plus 15 plus 22 plus 34. And then we're going to divide that by 7. That's going to give us our sample mean. So if I work that out, I get 13.7. I get 13.71428, but I'm going to round to the nearest thing. And this is going to be, our unit is going to be in items. Always very good idea to do your unit. Now median, since there are 7 values, it's just going to be the middle value. And there, remember, these are already in order, so that's very important. So it's already in order, so that looks like the middle value there. So the median is going to be 12. Again, we will show you ways to do this on the calculator, but for now, I'm just kind of doing it by hand. Now, center is great, but you can have lots of data that have the same center, but they're very, very different pieces of data, or data sets, pardon me. So what we're going to do is we're going to also do what's called the measure of the data, spread. So how spread out is it? So we'll start off with some very easy ones, and then we'll kind of progress to some more standard ones that are a little trickier to calculate. So the center of a data can be misleading, like in these 2 data sets. So these are 2 data sets, which is how long a paint that's painted on a house would last before it starts to fade. So there are 6 pieces of data taken for 2 ones, or 2 different brands of paint, and you can see the data here. But if we calculate the mean for both of these, the mean for brand A is 35, and the mean for brand B is 35. But if you look at these 2 data sets, they are very, very, very different data sets. I would say, if I was going to guess, I would say this one is a little more spread out for lots of reasons. It has some smaller numbers, it's bigger numbers, while brand B is a little more compact, is a little more centered, or a little more gathered around the center. So we want to be able to express that numerically. So there are lots of ways to measure data spread. We'll talk about one you've probably heard of from like middle school or so, and then we'll talk about the ones that we use a little more prevalently in statistics. So the first one you use is what's called the range. And the range is just really going to be the distance from the largest to the smallest number. Now the problem with this, or data value, the problem with this is it only takes into consideration that big number and that small number. Everything else in between kind of gets ignored. Similar problem with the median. The median only looks at the middle. It doesn't look at the bottom and the top. So for the range, it's a really quick one to do because, you know, the official formula for range, we just take the biggest value, the max, minus the smallest value, the min, and we can go from there. So if I was to do that for these 2 data sets, this range would be 60 minus 10, which is 50. And this range would be 45 minus 25, which is 20. So you can obviously see that the top one has a larger range, a larger spread of values. But it could be, in a data set, it's just that the top and the bottom number are spread out and everything else is very compact. Where another data set, everything could be at the ends and nothing in the middle. So for that reason, range is not the best way to go. So we're going to try to use a more standard unit to measure spread. And that unit is typically what we call standard deviation. Now, to get standard deviation, we'll also have to calculate a variance. But what a variance and a standard deviation is, and really what a standard deviation is, a standard deviation is how far, on average, does the data lie from the mean. So, how far on average does the data lie from the mean? Okay, that is what's called standard deviation. The variance is it's very related to standard deviation. They actually are basically the same number. One is squared and one is not. The variance is the squared distance, the average squared distance from the mean. But we really don't like dealing with squared distances. So generally we will stick with the standard deviation. So let's talk symbols, and then we can talk about the formula here that you see, which looks pretty nasty, but it's really not terrible once you get into it. So S is the sample standard deviation. So if you have S, it's the sample standard deviation. Sigma is the population standard deviation. Again, most of the time we'll be doing sample data when we do our calculations, but the population standard deviation also does pop up. The variance is just S squared and sigma squared. So these are things for variance. The first one, the sample, and our second, our population. So if you look at the relationship, variance is just the sample standard deviation squared, or standard deviation is just the square root of the variance. So both of those will work in this case. So what I'm going to do is we're going to try to work through this formula and show you how to do standard deviation. You can see the formula there, the square root of 1 over n minus 1 times the summation of x sub I minus x bar squared. The formula looks a lot more complicated than it really is. So what I really want to do is I want to go through the process, because as one part of the college curriculum, they do want you to be able to calculate standard deviation by hand. So we're going to show you calculator shortcuts here soon, how to find these things, but they do want you to be able to do this by hand, so that is pretty important. So we're going to calculate the standard deviation for brand A. So if you go up here at the top, brand A is the one that has data points, and x of I, anytime you see an x of I, that just means different data values. So 10, 60, 50, 30, 40, and 20. So those are my data values. So what we're going to do is, remember, we're trying to find the average distance the data is from the mean. So we want to see how far away it is from the mean. So the first thing we need to know is the mean. So remember, we calculated that from above. The paint lasted on average of 35 months. So what I'm going to do is, for this, I'm going to find out how far each data value is from the mean. So I'm going to take x sub I minus x bar. Okay. Some books do the opposite, x bar minus x sub I. It honestly does not matter, as you will see eventually, but this is how we're going to do it. So we're going to take each data value minus the mean. So we're going to take 10 minus 35 and 60 minus 35 for each one. So 10 minus 35 is negative 25. 60 minus 35 is 25. 50 minus 35 is 15. 30 minus 35 is negative 5. 40 minus 35 is 5. And 20 minus 35 is negative 15. So this is how far they are from the mean. The negative ones are smaller, the positive ones are bigger. And so what people originally thought was, well, let's just add these together and then divide by how many there are, and that'll be our standard deviation. But the problem is, you notice if I add all these numbers together, I get 0. And then 0 divided by whatever is 0. Well, this doesn't really have a spread of 0 because it's just basically canceling each other out. And for most data sets, you get something very, very small. So what we have to do is we have to kind of not consider the negative sign for now. We're eventually going to consider it again. We're going to not forget about it, but what we're going to do is we're going to first kind of get rid of the negative signs. And there's a couple ways to do that in math. You can take absolute value, which seems awful because at some point I want to undo what I'm doing. So we're going to do the other way, what I know that'll make things positive. I'm going to square them. So I'm going to square all the values in that column. So notice, this is x sub I minus x bar. This is just x sub I minus x bar squared. So we're just talking about this stuff here. So I'm going to square all these. So 625, 625, 225, 25, 25, 225. So now for each data point, I have its data value minus its mean squared. So now it says I want to add these up, so I'm going to add this column up. So this column has a total of 1750, I believe. Okay, so now we have all the differences in all the sum of the deviations is 1750. So now what we're going to do is typically we divide by how many there are for a mean, but for a standard deviation, what we actually do is we divide it by n minus 1. Now the reason we do by n minus 1, this is what's called a correction factor. For a sample standard deviation, we always divide by n minus 1 because it takes into account the data that we are gathering. For a population standard deviation, we actually wouldn't. We just divide by 6 and be done. So we're going to take 1750 and then we're going to divide it by 5. So if I do 1750 divided by 5, I should get 350. So what we've just found, believe it or not, we have just found the variance, the sample variance. So the sample variance is 350. So to get the standard deviation, hopefully it's not too crazy, we'll just take the square root. So the standard deviation is the square root of 350. And this would be, of course, the unit would be in months. Now, if you wanted a variance for, or a unit for variance, it would actually be in square months. So that's kind of a weird thing. That's why we typically don't like variance, because what's a square month? We don't know. But when we take the square root, we get in months. So the square root of 350, if I want to round it, it's going to be 18.71 or 18.7 months. So on average, the data lies about 18.7 months away from the 35-month average. So that's how we find the standard deviation. The variance is just the square of that. Pretty straightforward. All right, so what I want you to go ahead and do is I want you to go ahead and try to find the standard deviation of brand B. So I'll go ahead and I would tell you to pause this video because this is going to be the end of the first part of the video. Go ahead and hit pause, try to work out brand B, and then when you figure it out, go ahead and check it out. Hit on pause and I will have the answer on the screen for you. All right, hopefully you had a chance to work that on your own. Really important that you can do these. So the standard of the sample variance should have been 50, and that's 50 square months. And then your standard deviation is going to be the square root of 50, which is 7.1, and that would just be in months. So if you got that, good job. If not, let me know. We can kind of see what your work was. Try it again, see if you can get that answer. Again, you're just taking the data minus the mean, squaring it, adding it up, and dividing by n minus 1. Now again, there is a way to do the standard deviation and variance on the calculator as well. And again, I'll put that in our second video that you can watch and kind of see how your graphing calculator can actually find these values as well. For the rest of the notes, the measure of position and things like that, we'll do in a second part video. just so we don't do too much in each video. But so once you're done with this, watch the video on the calculator, and then you have an assignment for part 1, and then you have an assignment for part 2. But if you do have any questions, of course, let me know.